Okay, so scientific notation is quite straightforward, and it's really about moving decimal places to the right or to the left. And what you want to pay attention to is first this number right here, so the exponent up top, and whether it is positive or whether it's negative. We'll talk about what that means for your problem, and you'll see it as we work through it. So as you can see in this problem, I have 7.5 times 10 to the fourth power. This, like we said, we need to pay attention to the exponent. That exponent is positive. When the exponent is positive, it means we're going to move our decimal to the right. So if I want to write this number in decimal notation, and I have a positive exponent, then I'm going to take the number right here, whatever they happen to give us, and I'm going to move that decimal point 4 places to the right since it's positive. So 1, 2, 3, 4, and then I'll fill in those places with zeros. So my answer is 75000, and that's all. Makes sense? So there's my answer, 75,000. Any questions about that at all? Did you get yours correct? Yes? Anybody have questions about theirs? All right, let's go to the next one. Okay, I've got 2.86 times 10 to the 5th. So here's my 2.86 ready to be worked on. And I've got a power of 5. So that means I'm going to move my decimal 5 places, to the right or to the left. Well, since that 5 is positive, that means I'm going to go 1, 2, 3, 4, 5 to the right and fill in any open spaces with zeros, leaving me with 286,000 as my decimal value of what is in scientific notation. Decimal notation. Questions? Okay, let's go to the next one. Next one, 6.11 times 10 to the negative 2. Now, you can guess that in the event that our exponent is negative, instead of moving to the right, we're going to move to the left by that number of spaces. So I'm going to rewrite 6.11 here, and because that's a 2, I know I'm going to move 2 places, because that's a negative, to the left. 1, 2 to the left. Again, fill in any open spaces with a 0, so my answer is going to be 0.0611. Any questions about number 6? Anything I can help you with there? We good? All right, let's take a look at the next one. 5.23 times 10 to the negative 3. All right, let's write the 5.23. I've got a 3, so I'm going to go 3 places, negative to the left. 1, 2, 3, and fill in any open spaces with zeros, and so my answer is 0.00523. Any questions about that at all? Okay. All right. Number 8. Now, we have seen problems that have already been in scientific notation. The previous 4 problems are all problems that are expressed in scientific notation. Now, what is scientific notation? It is when you have a number, a decimal point, and a number. So the decimal point, it could be more numbers here, as long as they're not 0. This decimal point should only have 1 number in front of it. Just 1. It can have other numbers to the right of it, but there should only be 1 number, just 1, to the left of that decimal point so that it's in scientific notation. Notice 5 point, 6 point, 7 point, 2 point. All of these are scientific notation because they only have 1 number, 1 digit to the left of your decimal point. Now, if you look at this one, if we wanted 1300 to be in scientific notation, we know for certain that it would need to be 1 point something. You guys follow me? If we're staying consistent with writing these items in scientific notation with 1 digit to the left of the decimal, this has to be the way that this is expressed. Now, knowing what we did before, what would the exponent here have to be such that if we were to go backwards like we did in these problems, it would take us back to 1300? Well, think about it. That would be 1, 2, 3 places to the right. Since I would need to go 3 places to the right, this is going to be a positive 3. You guys understand that? Any questions? So the way to do it, there's multiple ways to look at it, but one way to look at it is place the decimal point where it's supposed to be with 1 digit to the left. And then ask yourself, how many places right or left do I have to move to get back to that answer? And use those rules, positive right, negative left, and the number of spaces to create your exponent. Are there any questions about your number? So the answer for me would be 1.3 times 10 to the third. Yes?
So I have 3,900 for mine. And so I just put the decimal in between the 3 and the 9.
Okay, good.
And then it'd be move the decimal 3 times.
1, 2, 3.
Yes, sir. And then it'd be x10 to the third power.
Times 10.
Times
It's technically not an x. Looks like an x, but it's actually multiplication. Times 10 to the what?
Third power.
Exactly.
Okay, so that's what I was putting in there. I'm trying to figure out why it was wrong.
Because you probably, if you're doing it, and I'll tell you this, let me show you why it might be wrong.
I think I see why, yeah.
This item on the palette. If you use an X, an actual X on your keyboard, it's going to mark it wrong. It wants you to use the X or the time symbol from the palette. Make sense? So it does tie into that comment about X versus multiplication. Good. All right, let's go to the next one. Okay, so I've got 38 million. So what am I going to do? I'm going to stick the decimal point right here. So my answer in scientific notation would be 3.8 times, whether I go right or left, I'm going to have to go right, so it's going to be positive, and all you have to do is count up your places. Well, you don't have to go and move it, count them up. 3, 6, 7. Or, yeah, count it. 1, 2, oh, I messed that one up. Let's redo that. Didn't move far enough. So 1, 2, 3, 4, 5, 6, 7. You get what I mean there. So there it is, 3.8 times 10 to the 7. Did you get yours correct? And again, remember to use the times symbol, the multiplication symbol on your palette to input your answer. Okay, let's go to the next one. 0.0095. Now, let's take a look here. This looks a little bit different than the previous 3 because we have a decimal that's over to the left, right? This is a smaller one. Well, the rule still applies, or the methodology still applies. Place where the decimal would be to only have 1 digit to the left of it. That means that mine would be a 9.5 times 10 to the something. Are you guys seeing how I just did that? Please ask if you're not sure. Remember that in scientific notation, there should always be 1 digit to the left of your decimal point. And so when I place that decimal point here, it gives me a 9, that 1 digit to the left. And now, count it up. 1, 2, 3 to get to the original answer. And that's to the left, 3. Any questions about that? This one's a little bit more tricky. When they are 0.0 something, or a small number, or not a whole number, it's a little bit more tricky to see for some people. Any questions about number 10? Okay, number 11. Another slightly tricky one. All right, so like we said earlier, you need to have one digit and only one to the left. And so if I place my decimal right here, that would set me up with an 8.5 times 10 to the something. So that is going to be how many places? Well, you can just count up. 1, 2, 3, 4, 5, 6, 7 to the left because I have to go this way. So you don't have to go and make all those marks. You can just simply count left or right from your decimal point, and however many places that is, that's going to be your exponent, and what direction is going to give you your positive or negative. There are 1, 2, 3, 4, 5, 6, 7 spaces, or counting this way, 7 negative, negative 7. Any questions about that problem? Okay. All right, so this is kind of the final stage. We're almost done with this section. We don't need to go all the way to the end. We're doing the basics of scientific notation. This one is clearly almost in scientific notation. It's almost there. Why is it not in scientific notation? Because it's not in this format, and so on, where one digit is to the left of your decimal point. If this was correct, it would be like this, 8.0, where the decimal was here. But instead, that decimal is too far over. Now, a lot of students, it's a little bit tricky to see. So if it helps you, go and write it out. 0.08, 10 to the 7th is 1, 2, 3, 4, 5, 6, 7. And so if you go and fill all those in, that actually gives you a number of what? 800,000, 800,000. How can you make this become 800,000? Well, it would be what? The decimals here, 1, 2, 3, 4, 5, 10 to the 5th. In other words, since I had to move this decimal place in the original problem 2 to the right to get to the right spot, I take away 2 from the original. Make sense? Any questions about that? It's a little bit tricky. And if you're not sure, just convert this to a whole number, and then you can work backwards off of this one. It's completely up to you. Does anybody have a problem that I can do for you? You guys all right? You let me know if it's not making any sense.
I got 0.80
Okay.
times 10 to the 4th.
Okay. So what would this be if we were to write it all the way out? If we were to write this as a whole number, how many places would we go?
4
To the,
right,
okay, 2, 3, 4. Tell me the number that results.
8,000.
Very good. So 8,000. Where would the decimal need to be in the right place?
1 to the right of the 8.
You got it, 8.0. So if it was in the correct spot, which is here, how many places would we need to go from there?
Which way are we going?
Well, to get to this one. In order for this to turn into this, how many places would it need to go? Or for this to get to that?
4?
Are you sure?
No.
I've got 8.0 here. I've got to go how many places to get to 8,000?
Oh, 3?
Correct. 8.0, 1, 2, 3 gives me 8,000. 8.0, and you just got to work backwards like this. 8.0 times 10 to the 3rd would be 8,000. In other words, to get this one to look like this, I needed to move 1 to the right, which means I decrease that one by 1. Okay, any other questions? Okay. All right, and that's it for that section.